This video, this is my first one. We're going to talk about how you actually graph a rational function. In the previous videos, we've talked about vertical and horizontal asymptotes and how you find those things, but we're going to dip into now how you actually come up with the y values, or the general behavior of this graph. So what I've got here are guidelines for doing this. It's a series of steps that we go through basically every time we graph a rational function, but we say again, any rational function is some f of x where we have some numerator over some denominator, okay? And these are just polynomials. So step one, and this is actually kind of an important one, it's going to be boring for this video because nothing simplifies. They give us easy rational functions, but always simplify f if possible. And what you want to write here basically is this. So you say factor the num and the denom. And the thing that we're looking for are any common factors. We want to divide those out, okay? So we're assuming going forward that we've gotten rid of any common factors before we do any of these other things, okay? But step two, it says, all right, let's find and plot the y-intercept, if any, by evaluating for f of 0, essentially. We say the y-intercept is always what you get when you plug in 0 for x, okay? So we're just going to list these things out here, and I'll even put them in order. I say number two, the y-intercept. So y-intercept means we're plugging in 0 for x. What do we get for y? And I notice that if I were to plug in 0 here, I get 1 over, let's see, 0 plus 3, so I'd get 1/3. Okay, so this means that the point 1 comma 1/3 is on this graph. And so we want to go ahead and put that on here. The important thing is that 0 comma 1/3, we're going to have to label it when we kind of get down to the nitty gritty because we're not going to be able to tell exactly what that point is without you telling me. Number three, it says, all right, well, let's find the zeros of the numerator, if any, by solving the equation numerator equals 0, and then plot the corresponding x-intercept. So basically, we found the y-intercept. That's what we're doing here. Now we are finding x-intercepts. And what we're saying is, well, the only time that we would get an x-intercept is if we set y equal to 0. And noticing here, if I set y equal to 0, I get this expression, 0 equals 1 over x plus 3. And the thing that's important to recognize here is this: when you deal with a fraction, I mean, what's the only time? If I had, say, a over b and I told you that it equaled 0, which part of this fraction must have been equal to 0? It had to be the numerator. So essentially, what we do is this: you just set the numerator equal to 0 and solve for the x values that cause this to be true. The nice thing about this polynomial is that I'm saying 1 is in the numerator, and if I set this equal to 0 and I say, okay, so what could I put in here for x that would cause 1 to be equal to 0? Well, that's the same thing as saying, what could I plug in here for x that would cause the sun to, rise in the west and set in the east? That ain't gonna happen. So the thing is this: we say that there are no x-intercepts since there were no x values that cause the numerator to be 0. So we're gonna write this out and we say no x-intercepts, and we're about to find out why there are no x-intercepts on this puppy here. But we say no x-intercepts, so I'm not gonna graph any here. Step 4. So what do I want to do next? I found the x-intercepts. I found the y-intercepts. 4 says, all right, let's find the zeros of the denominator. Okay, why would I want to find the zeros of the denominator? Why would I want to find what causes this to be undefined, basically, is what we're asking, because that's where our vertical asymptotes are going to be. So basically, we found the y-intercepts, you find the x-intercepts, now we're going to find the vertical asymptotes, followed by, in a minute, horizontal. But we say the vertical asymptotes are going to occur wherever this bottom expression is equal to 0. So number 4 here, all we do is this: we just say take x plus 3, let's set it equal to 0 and solve it. And what I discover is this: -3. Well, I have a spot where I'm going to have a vertical asymptote. So we say vertical asymptote. Literally, this is what I'd rather write instead of 4, and show my work. I'm just walking through these steps here. But you write vertical asymptotes. We say at x equals -3, we have a vertical asymptote. So I'm going to go put this on our graph here. We say, okay, so at -3, we have this imaginary line that as we get closer and closer to this x value, our y values are either going to go to positive infinity or negative infinity, and we want to label this. So we say x equals -3. Now, let's go ahead, number 5 here, it says, all right, let's find and sketch the horizontal asymptote, if any exists, by using the rule for finding horizontal asymptotes of a rational function. So I'm going to write this out here. We say horizontal asymptote. We found the y-intercept, found the x-intercepts. Let's find the horizontal asymptote, if it exists. And what we do is we compare the degree of the top to the degree of the bottom. Now, I know that this sounds kind of wacky, but we could imagine the top here is having x to the 0, because recall, anything to the 0 power is 1. But the only thing I want to point out here is this: the degree of the top is 0. It's a constant function. The degree of the bottom is 1. It's linear. So this is a bottom-heavy thing. And we know that when we have a bottom-heavy thing, we can just say that it's the x-axis. Now, I need everybody to be prepared to write the equation of this horizontal asymptote, but now we're just going to go put our asymptote on the graph. Okay. So up until now, here is it. This is all we've done. We went and found the y-intercept. We went and found any x-intercepts if they existed. They don't here. We went and found the vertical asymptote. We went and found the horizontal asymptote. So what do I have left to do? Basically, what we're going to do is we're just going to plot at least one point between and one point beyond each x-intercept and vertical asymptote. So basically, I had no x-intercepts, so I don't need to plug in any x values in between or outside those. But I am going to plot some x values to the right and to the left of every vertical asymptote to give us an idea of behavior. And actually, the more points we plot, the better. So I'm going to go ahead and make this table here, this xy chart. We say x, y. And so some good x values to plug in. Since we had an undefined spot at -3, let's do this. Let's plug in like -5 and -4. 2 spots to the left of that, and then we'll just do 2 to the right. If I plugged in -2 and -1, this is going to give us an idea of what our graph looks like. So now, with rational functions, it looks like we have 1 over, and then we say, input plus 3. Essentially, we could just put in this -5 down here and leave it rational. I mean, you're going to get a fraction, but we say we get 1 over, it looks like here, -2. So this means that we're going to get an output of -0.5 when we have an input of -5. And again, if we were to plug in, say, -4 here, -4, -4 plus 3 is -1. So I would get 1 over -1. But that whole expression simplifies down into -1. So we say this is going to have an output of -1. Let's check -2 here. When I plug in a -2, the denominator becomes 1, so I get 1 over 1, which that whole expression is just 1, so we can simplify that down to 1. And last but not least, when you plug in a -1, looks like the basement comes out to be 2, so I get 1 over 2, and so I get a half. And so basically, to sketch this graph, we're just going to plot these points. Now, we are not leaving from this. This is not what we're leaving from. We're leaving from the origin. I remember paying attention in algebra, so let's not mess this up here. We say, I'm going to go left 5, down a half. So I go 1, 2, 3, 4, 5, down a half. We're going to drop a point right here. And we don't have to label this one because I've already included it in our table. So just leave your table down here. We say -4 is going to be at -1, so we'll drop that point right there. And let's go to the right of this. We say at -2, we are at a height of 1, so -2, 1 is here. And then we say -1 comma a half is here. Now, the thing is this, we're going to use what we know about asymptotes to kind of sketch in what we think this looks like. And the things I want to point out are these. Horizontal asymptotes, out on the ends, way out on the left, way out on the right, our graph is going to get really, really close to this asymptote. So it doesn't matter that it touches the asymptote when you draw it here because you already labeled it and you said, well, look, it's an asymptote. So I know it looks like it's touching it, but I said it's not. Okay, and we know that vertical asymptotes, as we approach this x value from the left, our y values are either going to increase or decrease without bound, and we have evidence to suggest that this one is going to decrease without bound. And likewise over here we say, well, really close to the asymptote. I don't usually draw from right to left, but I would go through my y-intercept here and up, and I would have this rational function that looks like this. So that's a pretty good rational function, if I do say so myself. So let's go ahead and take a look at this other one really quickly, g of x. We're going to go a lot faster on this one. So starting with the first thing, we need to factor the top and the bottom. This is already about as factored as you're going to get. So essentially, I noticed that nothing cancels out. So we're simplified. Okay, check. The next thing we want to do is this. We want to find the y-intercept. So y-intercept, this is plug in 0 for x. So we say y-intercept. Let's just write this out. The y-intercept, when I plug in 0 for x, I notice that those two terms would drop out. So I get 3 over 1. So my output is going to be this. We say when I plugged in 0 for this, I got 3 over 1, or I got 3. And I'm actually going to go put that on my graph right now. This thing right here that I realized I didn't label on the last one. Sorry. Now x-intercepts. We say x-intercepts occur where the y value equals 0. If I were to set g of x equal to 0 and go solve this, the important thing to recognize here, and I mentioned this over here again, is you only need to set the numerator equal to 0 because the only way a whole fraction is 0 is if the top is 0. So, maybe off on the side I say, well, 3 plus 2x equals 0, so 2x equals -3, and I get x is -3 halves. Okay, so this means that I only have one x-intercept. It occurs at -3 halves, comma 0. And I've written this down here, so I kind of probably should label this point exactly with what it is, but I just know that I have a point in here. I'll try to narrow it down there. But I've listed that there. Okay, so moving on, we say, all right, vertical asymptotes come next. We know that vertical asymptotes occur wherever this whole thing would be undefined. So basically we're saying, where would the basement be 0? Where's the denominator 0? So if I set this equal to 0 and I solve it, looks like we get x equals -1. So we say it has a vertical asymptote at x equals -1. We're going to go ahead and drop this in. So we say, all right, -1. We're going to go ahead and drop in this vertical line. You need to label this x equals -1. And then let's go ahead and find the horizontal asymptote now. It either has one or it doesn't, and we compare the degree to find the horizontal asymptote. That's a rule. And so we say the degree of the top. Careful, the degree of the top is this x to the first here. Let's switch this to blue. X to the first over x to the first. Oh, so it's balanced. So since this is a balanced thing, we do actually have a horizontal asymptote, but it's at the ratio of the leading coefficients. And so I notice that the leading coefficient at the top is 2, leading coefficient at the bottom is 1. So I get 2 over 1. So I have a a horizontal asymptote at y equals 2. So here is our horizontal asymptote right here, and we do want to label this at y equals 2. So now that we have got our y-intercept, any x-intercepts, we're just going to plug in some extra x values. So we say, let's make a table. You need to make a table. Do not make a table. It means do make a table. So it looks like we're going to plug in any x values to the left and right of any, say, intercepts. So I'd plug into the left of this negative 3 halves intercept. Actually, I'll just go ahead and say, since we're undefined at negative 1, let's plug in, say, negative 3 and negative 2. We'll go 2 spots to the left of our asymptote, and then 2 spots to the right of our asymptote. So we'll plug in 0, and we'll plug in 1. And we can show our work here. It looks like we have 3 plus 2 times my input over 1 plus my input. This is our expression here. I like to just write it this way and then use, say, pencil or a digital stylus. So we say, all right, 0 is easy to plug in. Why don't I start with 0? If I were to plug in a 0 here and a 0 here, I'd get 3 plus 0 over 1 plus 0, or 3 over 1. Okay, so 3 over 1, we know that simplifies down into 3. So we say at 0, we're at a height of 3. I'm going to go put that on my graph. We say 0, comma 3. Oh, it's already on there. So we did find a y-intercept. So now let's plug in 1. Looks like we get 3 plus 2 times 1 on top, so I get 5 over, and I say 1 plus 1 in the basement, so 5 halves. That's not hard. We say that's 2.5. You may certainly use a decimal if you like. I like leaving it as a rational expression. So we say at 1, we're up 2.5 units, so that would be right here. And then on the left side, we say if I plug in negative 2, negative 2, negative 2, looks like we get this. We say on top, we get 3 minus 4, which is negative 1. In the basement, we get 1 minus 2 is negative 1. So I get negative 1 over negative 1. That's going to be 1. So when we plug that in, we got 1. So negative 2, comma 1. So left 2, up 1 is on my graph. And then we say, okay, well, when I plug in negative 3, what are we going to end up with here? So we get 3 plus a negative 6, which is a negative 3. In the basement, I get, we're plugging in a negative 3, sorry. We say we get a negative 2. So we get basically 3 halves, or 1.5 if you're into the whole decimal thing. So I'm going to go left 3, up 1.5, draw a dot right here. And then to the best of our ability, we're going to graph this in knowing what we know about the behavior around the asymptotes of a rational function. But that's basically how you sketch out rational functions. You just go through those steps.